All right, welcome everyone to SolidWorks Live Design. Live Design is where we try to bring you the best of tips, tricks, behind the scenes insights into designs from some of the best engineers, designers, and SolidWorks users in the world in an attempt to share information and to grow this community of learning together. My name's Steve Fick, and I'm excited to bring live design to you today with a guest, Jeremy Fielding. Jeremy, you may know, is a skilled teacher. He's an amazing engineer, and you likely have seen him on his YouTube channel, Fielding. And so, Jeremy, welcome to SolidWorks Live Design.
Hey, thank you for having me.
Yeah. Hey, and as we get started here, maybe as a way of introduction, can you share a little bit about yourself and what you're going to cover with us today?
Wow. Well, I'm Jeremy Fielding. As you've already heard, I design and build all sorts of interesting contraptions with the primary intent of talking about this thing I love, which is engineering. My not so secret goal really is to find all those young versions of myself and hopefully inspire them to take on this career that I love. So that's really what my life's mission is currently. The project that I want to talk to you about today is a robot that I designed a couple of years ago. It's one of the largest and most difficult projects I've ever worked on, and so I thought this was a good place to start. The idea to talk about it on this show actually came from a comment of all places. Somebody was commenting under an engineering video, not on my channel, where they said they were basically just ranting like, "Oh, it should be this way, it should be that way, and period. This is the way you do it." And I'm just shaking my head, going, "No, nothing in engineering is like that. Everything in engineering is a trade-off. There are always choices being made. You got to work with stakeholders, with budget, with time constraints. So why not use one of my projects to talk about, how all those things affect where your project goes?"
It's great. It's really kind of an analogy for life, right? It's
Absolutely. Nothing is as simple as you like to think.
What do you think? Yeah. Well, I'm excited to dig into to this project with you. I was watching back some of these videos, and you always see you try to incorporate SolidWorks, at least some screenshots, in a lot of the Jarvis videos. And when we had a chance to bring you on, I was like, this is going to be fantastic to actually dig into the model, maybe some of your strategies around the design. And I think you're also going to touch on moving parts and cables, and then some tips and tricks as well, right? Throughout
Oh,
the
absolutely. I'm glad you reminded me. I do have that in my notes over here, but yeah, that was I picked that because it's one of the components that I spent a lot of time thinking about. How do I manage all of these parts that require electricity and signals and on-off switches? So absolutely, it was one of the bigger challenges in building this project. And then of course, some tips and tricks for SolidWorks, because I just felt like I should talk about that. This is SolidWorks.
Well, it's great. So this is one of my favorite things about this show is the fact that we kind of get to go in the cubicle, get over your shoulder, and just see how you approach this. So let's, if you're ready, let's dive into it and see what we've got.
Absolutely. So I guess probably where I want to start before I even actually, let's pull up the model and I'll show the model first. So this is Jarvis, and it's a 7-axis robot arm. The full reach, when this extended all the way out, is almost 1.5 meters. So it's a very large robot. And when I was thinking about designing this project, one of the first questions I always ask is, what is my design intent? Like, this is before you make any sketches, before you put anything in the model, you want to know what is the problem you're trying to solve. And an analogy I've used in a previous video that I'll tell you more about later is, you can the way you ask the question is very important. If I want to, let's say, for example, I want to design a more efficient lawnmower, could be one way to ask the question. And another way might be, I want to shorten so many acres of grass in so many minutes. So when you present the question in those different ways, they can lead you to very different solutions, right? The first one makes you think about fuel economy and the blades and all the things that about the lawnmower as it exists today. And the other one opens up all sorts of opportunities, right? Very different equipment. Maybe you use chemicals. Maybe you tear out the grass and use turf. Like there's so many different ways to solve the problem when you think about it that way. Now, for this robot arm, interestingly enough, my whole goal was actually to teach engineering.
Mm.
And I wanted to do that with a robot because I was really excited about actually building a robot myself. So my two initial premises, which are kind of weird for engineering, but it worked for me, and that is, uh, can a guy design and build a robot from scratch by himself in his home garage? That was number one,
Okay.
and I was determined that I could do that. And number two, how do I use this to teach people about robotics? And so, with those two things in mind, I started to design this robot here. And I came up with some design parameters, how much reach did I wanted to have, what kind of load capacity did I wanted to have. But I guess the thing to keep in mind is I wasn't constrained. These things weren't constrained by some end task in the same way that if you were designing a robot that could work in a Toyota factory and lift a car door over and over all day, that would lead to one type of design. But for me, a robot that wouldn't be used very often and was primarily used to teach people about robotics and do things in a home shop where you may only program it to do this task once and then you would change the program. That's kind of what was going on with this. So uh, I don't have quite the time to get into all the design choices, of course, but I really wanted to bring up that there's a whole series of videos where I go into much more detail about the load capacity and the various components that ended up in this design. I ended up dropping this last component here, so if you go and watch the whole series, you'll notice there is no track, and that's because at the end of the day, it just took up so much space in the shop. It just
Mm.
it just wasn't worth it, and I decided to drop that component. But that's the only thing that ended up changing about this design. Everything else you see here has a real life component,
Nice.
and I'll even say I have a couple of clips. Not that one. Where'd you go? I actually have them. Here we go. So I put this clip in here mostly just so that you could see it moving around and get a good idea of how big it is because the 3D model doesn't reveal that very well. But as you can see, I'm just testing that all of the motors are moving in sync, that the reverse kinematics are working properly. You see it's able to keep the plate level, that kind of thing.
Yeah.
But
Yeah.
one other thing I want to bring up as we kind of move on to the next topic, and this is a good place to do that, is cable management, which is what you see going on here. And I'll show you another view, which will help with that.
Yeah. This is fascinating because, like a robot, like it's there's a lot of disciplines going on with a robot, not only from the design, but the engineering, the kinematics, the cabling, all of this. And like, I applaud you, man. This is not an easy task to bite off to just be like, I'm going to go build a robot.
I think it's yeah, that was definitely by far one of the most difficult parts is working across so many disciplines. I, I think that's worth talking about for a moment because for me, the programming was by far my weakest discipline. I had the least amount of experience there, but I would say that the 3D, the mechanical design was probably the easiest part, although this was definitely a challenge in design. But just compared to the other skills involved in terms of welding, machining, and the electrical design, I felt pretty comfortable with, except there were a lot of new things that I was working with here to make this work that I had never used before when designing the electrical system. So it was quite the challenge. And
Yeah.
then especially the programming and the reverse kinematics and these were things much of which I had never done before, and to try to incorporate that in a new difficult project that already had many challenging aspects to it. That
Yeah,
was
we're getting some
that was
great
quite difficult.
questions. Jeremy was asking how did you learn all this, which is great. And then Marcus is, this looks good. Even the color looks friendly. Do you think it could lift 25 kilos? kilograms?
Oh, not 25 kilos. I designed it to handle about 8 kilograms, which is about 16 pounds. And so it could handle that pretty well. And it also depends on the gear ratio that I use. I have it set up so that I could change the gears out and get it up to about 30 pounds, which is roughly 16 kilograms. So that will be moving very slowly though. So
Yeah,
just like I mentioned at the beginning, everything in engineering is a
that's
trade-off.
great.
And so the way it's configured right now, it could handle about 8 kilograms, and that's about as much as I'd want to put on it before you might start to have some issues if you went much heavier than that. And in terms
These are
of
great
learning, I'm
questions.
pretty much self-taught. Sorry, go ahead.
Oh no, go finish your thought. I didn't mean to interrupt you.
No, it's okay. So basically, I'm self-taught. I bought books for several things, and also a lot of YouTube and internet searching to see how people were solving various problems. I would describe it as sort of a very exploratory job. I didn't try to research everything at the beginning. As I approached a problem that I didn't understand or something I didn't know, I would explore that one problem. And then when I solved that problem, I would go back to work. And many problems came up along the way that I had to figure out, how do I make the program behave the way I wanted to make it behave, which is the thing I ended up spending the most time on. And but even things like deciding how I wanted the e-stop to work, that turned out to be a surprisingly difficult problem, because if you make everything shut off, then the robot would drop the load, right? Like you can't do that. And so I ended up incorporating brakes in the system that would basically freeze everything where it was if I lost power. And
Sure.
so, do you want it to forget what position it was in? And then you have to reorient all of the axes again. So there were a lot of interesting problems that came up along the way related to that, all of which I would look and see, well, how are robot companies solving these problems? And of course, all of them, their software is proprietary, and their methods are proprietary. So nobody's just going to say, this is how we do it. You, you have to you have to figure it all out as you go. So
Yeah,
the short answer is, it was very hard.
got it. So I think we were going to transition into the cable management, but maybe as we transition into that,
Mhm.
what outside of the engineering, do you have a plan? Like what's the plan for the robot to be used for? Noah was asking in the chat.
Okay, so the plan for the robot was twofold. Number one, um, to actually accomplish building the robot. That was number one, prove that I could do it. And then the second part was to use it to make a series of videos uh, teaching people about robotics, which I ended up baking into the series as I built the robot. So I guess the short answer is, I've already accomplished what I wanted the robot to do. So if it sat and gathered dust forever, it will be okay. Like, it's already done what I wanted it to do. But I do occasionally use it to play around with, say, for example, if I wanted to mount a camera to it and have it record interesting angles, something that would be really difficult to do manually.
Yeah.
I've used the robot to do that. And in one of my videos, which we're going to link below, the where you see, it's kind of like the season finale. It's the summary video of the entire project. At the end of that video, you see me attach a torch to the robot and plasma cut some shapes into a piece of square tubing. And so I have used it for that. When you have something that would be really difficult to do manually, the robot could do it perfectly.
Hmm.
But again, it's really already accomplished what I wanted to accomplish. So
Yeah.
it's okay if I don't ever use it again.
That's awesome.
Yeah. So thinking about cables, I wanted to show this view because it gives you a chance to see just how many cables there are. So here you can see all of the motor controllers. There's 6 on this side, and there's one more at the bottom, which was for the track that I ended up not installing. But you can see all the cables on the floor. And if we have a back view somewhere in here, Actually, how about we switch to a photo? And that's a better view. You can see all of the cables coming in and out of the robot. So keep in mind, there are limit switches, there are the motors themselves, and then anything that I attach to the end of it, there's pneumatics. All of these components need power, and you need some sort of way of getting all of that up to the end. Well, you obviously don't want to just twist and bend these cables over and over again. And I
Right.
essentially had just a handful of options. I could use something called slip rings, and I have a picture of that. Let's see. So you can buy these devices. They're called slip rings. This is what an example of what one would look like. Let me zoom in a little bit. You would attach this to the robot. One of the components is free to move, and the other side will stay stationary with the component. And going back to the other photograph, you can see that the cables will slide along with little brushes that allow it to stay in contact without bending and flexing the wires over and over again. I considered this option pretty heavily, but the problem with it is I didn't want to wear a component. That was the main reason I opted
Yeah.
against this. Eventually, these brushes will wear out and need to be replaced. And they also require their own space internally. And so rather than design around them, I decided to use what I saw many of the large robots using, which is this snake-like cable tray that you see on top. Now,
Mm.
if you've seen a CNC machine, which I imagine many of you have, you would see something like this, which is just a cable tray that flexes in one direction. But I needed something that would bend around a six-axis robot arm. So the next variation would be, this cable tray that you see here. And related to that, you need maintenance, and that's what you see down here at the bottom. All of these disconnect points where I've got these quick release plugs that allowed me to disconnect these cables to troubleshoot problems. And I wanted to bring these things up because I think these are important things to consider. Where do you want disconnects? Because every place that you have a disconnect, there's a risk of wires being short, having damage. There's potential for cable interference. I mean, signal interference. So you want to be really careful about putting ground wires next to AC wires, because these motors are 240 volt AC, and that will interfere, especially with your low voltage DC wires. So you got to think carefully about which ones you put in which cables, which ones disconnect where. These are all things you want to think very carefully about. And I thought it was worth bringing up because I actually had some interference issues, and I ended up moving some wires to different cables in order to get rid of that interference. So this is a really, you can't understate how important this part is to making sure that your robot will function properly and that you don't have limit switches going off when you don't expect them to, and different things like that. So
Is that so? Is that something that you anticipated, like you knew was going to be a challenge, or was that something that you got into it and you started running into issues and you're like, oh, I didn't even realize that this was going to be something I needed to be concerned about?
I would say it's both. I thought it would be an issue, but it was more of an issue than I expected.
Okay.
And so as I was trying to anticipate problems, there were yet more problems that came up along the way. It was more difficult than I thought. And that's another reason why I thought it was so important to bring it up here. You
Yeah.
have to be really careful with, um, especially mixing your AC and DC wires, putting them too close together, and being really careful with uh, the places where you connect and disconnect. Every place that you have a cut in the wire, there's a potential risk that something isn't fully seated properly, something isn't connected properly. You want to be sure you've crimped that wire really good.
Yeah.
I'm bringing these up because these are all issues that I had along the way. I mean, I don't remember how many cables there are, but there are over 100 wires, coming into
Holy
this
cow.
robot arm.
Yeah.
I mean, each motor, you've got the three wires. It's three-phase AC. You've got two for brakes. I don't even want to try to number them all, but there were a lot of wires. And then you multiply that by six motors. and then you add onto that all of the limit switches. There are a lot of cables going in.
We did have a question come in. How long did it take you to complete this project? Given all the things you had to troubleshoot, like this concept from prototype shown in the video.
Well, so the very first, what I'm going to call the prototype version, from zero to having the robot moving, it was only about 3 or 4 months. And that's because the initial part of this project was sponsored by SolidWorks. And I essentially promised I would do it in that time frame. And so it was just mad dash, staying up all night, like doing whatever I could to get it done. But from that beginning phase to the robot is everything works exactly as I wanted to, the version that you see on the screen, it was about 2 years.
Okay. Wow.
And that most of the last year was working on the programming. And then eventually I ended up switching to a different controller because I found a controller made by a company, which I won't mention here, but that turned out to be just a better fit overall for my needs.
Yeah.
And the way it handled the e-stop and that kind of stuff. It was nice to take all of that stuff off of my plate and have something where I could hold the controller in my hand, have the dead man switch. It just added a few extra things that made it really polished. And
Nice.
So in the end, I was using an off-the-shelf controller to move the robot.
Gotcha.
Mm-hmm.
Awesome. So you had to figure out the cabling, all of that. Was that also something that you ended up mapping out in SolidWorks, or was it something that you just did kind of in the shop as you went?
Well, one of the things that I did, let's unsuppress that. All right. So while I was thinking about that, I did model out the control box just to get a sense of its space and hardware. Had to make sure that I had the spacing right for airflow, circulation, that kind of stuff. But I didn't model the cables just because I needed them to move in so many different directions. I didn't feel like it made sense. There's a sketch in here somewhere. That one where I did use a few sketches to make sure I had the lengths correct, and for that snake cable tray that I have on the back of the robot, and that's one of several sketches. I won't show all of them. That allowed me to just make sure that the cable length was correct, and that even when I flexed it in all the different positions, it would have enough room to move the way I needed it to move.
Yeah.
So
I think that's an interesting point that I even remember when I was doing machine design, is sometimes this combination of 3D models with 2D sketches is really powerful, because sometimes you just need a length, or you just need a real basic sense of, what's going to happen. And the sketch is great. It's enough,
It is. It is. Even when you think about just bending around a corner, and like sometimes, it seems more complicated than it is. But if you just, make a circle with a radius, and then you make sure that it's the right radius.
Yeah.
It doesn't matter if it's flat or if it's, bent in 3D. Very often that can tell you a lot about, what you need to know.
Yeah.
And I think one of the more interesting things is, like, even if we zoom into here, there's a belt that actually bends 90 degrees in the wrist to come around 2 rollers here. And then that's what allows me to flex the wrist of the robot. So that was really challenging at first. It's like, well, how do I make sure the belt length is correct? Because I also need to be able to tension the belt and release the belt while it's bent around 90 degrees. But I ended up just making a couple of sketches, and that was enough to get it all worked out. So
yeah,
I didn't initially think I could solve that with 2D sketches, but I did actually end up solving it. Getting the length correct, and also making sure I could tension it. It tensions in this direction, but the belt bends around here, and it worked out just fine.
Nice.
Yeah.
Are there some other tips and tricks that you would love to, or would like to dive into with us on this?
Oh yeah. So well, uh, hopefully the people watching this have watched tips and tricks videos before, but there are a couple that I think are so important that even if you've seen this before, it's really important to remember that you have these options. And the first one is templates. So all of my parts, for example, if I go make a new part, here I've got some pre-made templates. This is so important, right? Over here, you can see, let's just use my part template 2024. And you can see, even when I open this up, looking over here to the right, I already have 3 axes that they exist. Why? Because I make them every time. So rather than have to make it over and over again, just go ahead and create a template with all of the features that you use on every part that you make. Almost everything that I design has moving parts. And because it has moving parts, there's also usually a motor, which will be aligned on over here. You can see right. And it also says shaft axis. I typically design my motor around that axis. And so I'm going to make that axis, go ahead and make it based on the major planes. Oh gosh. Okay. There's so many places I could go here. Thinking about the main planes. This is one of my pet peeves when I get a 3D model from someone else who has just picked some random plane and then they start designing a part that's symmetrical, but it's not symmetrical about one of the main planes. Maybe they use faces and then they create some plane that's way down in the 3D model. Stop doing that. Don't do that. Don't do that to yourself or anyone else. Use your main axis or your main planes. And I like to think of this as, and it's your foundation, right?
Yeah.
You built everything off of that. And so this model, even as complicated as it is built around the main planes. And then I also have another 3D model. I want to show you this one because this one has more symmetry. You can see that it's one of the planes is about the wheel, the motors that you can see there, and then the right plane right along the center of this cart because it's symmetrical. This allows me to mirror parts from one side to the other. Many of these parts are mirrored. So use the planes that are there as much as possible. That will save you so much trouble.
Gotcha.
And there's one more tip that I want to bring up before I forget. And that is something that I like to call my primary sketches. Let's open this model. So here we're in a simple part here. Right here at the top, you'll see I have a couple of sketches. This one is called the right view sketch. And then I have another one that got buried. Let's look at that. So this sketch controls about 90% of the model. And so rather than going through having to comb through all of these different boss extrudes and swept cuts, all these different things that you have going on to try to find the sketch that you need, you can control nearly the entire model from one place. And that makes your model so much more stable. Let's back out of this for a moment and then I'll come back. Here's a thing that just bugs me when I get a model from someone else. You can tell I've worked on teams, right? Where people have all these bad practices. They will click on a face and then start sketching on this face and something will be built off of that. And then later on, because this will happen, this face will, something needs to change. The chief engineer is like, that's stupid. Get rid of that and put something else there. You delete this face and now you have all these red components and mates are broken. All this stuff is gone. Rather than sketch on a face, you could sketch on the right plane and then you can still put it wherever you want just by using features that will allow you to put it here. So, all right, let's say I want something on this face. I can actually put my sketch on the right plane and then use my, let's open this back up. And then I can use this top sketch that I made, which is all the way at the top of the tree. This is my foundation. It never changes, right? And I can use points in here. For example, I can use that point to start my boss extrude. So I have a whole video called 50 Tips and Tricks where I show you exactly how to do the things that I'm bringing up. So it will be worthwhile to check that video out. It's much more detailed and you can watch it over and over. But if I base that boss extrude from this point, it won't just vanish. It won't ever lose its foundation. It'll stay in place until I'm ready for it to leave. And you can also add names like overall width, to define what these sketches are for. Because if you work on this 6 months ago and then you're forced to move to a new project, you come back, you don't remember what what all of these dimensions do. Just go ahead and add a little description. While I'm talking about descriptions, you can also name your features and then search your feature tree, right? Like come up here and search for GPS, and you can find those components related to the GPS. Things like that. This can save you so much trouble if you just take the time to name your features rather than come here and you have 1,000 things named boss extrude. You don't know which one is which.
Right.
Oh my gosh.
Yeah, I think you're bringing up some good points. Like a lot of people don't realize, like on the template topic, that especially for parts, not only can you have like reference axes and planes, but you can actually have full pieces of geometry. Like if you always start with this same chunk of geometry as a starting point, like you can have that in the template and it's just there when you're ready to go. And layout sketches, I love. I'm a huge fan of layout sketches, right? Because you're right. It's like just go to that one spot and it can control everything else in that model if you want it to.
Oh man. Oh, okay. So I have one more tip that I want to share before we go, which is a shortcut, and that's just the S key, right? If you hit the S key, you have this pop-up menu that is customizable right next to your mouse, right? And you can just click on whatever you want. There's sub menus in here. But what's even better than that is that shortcut has all the shortcuts under it. So if you hit S and then just start typing boss extrude, everything that you could want under every menu is right next to your mouse. You don't have to go up to the top. Like this is by far my favorite thing that SolidWorks ever added to their montage. It's been there for a long time, but I can remember when I first figured this out. Oh my gosh, this just changed my world. I used to waste so much time going up here to try to search for things, or even looking through these menus and trying to find the thing that I wanted. But now I can just type the thing that I want and it's right next to my mouse. That is huge. You should get used to using those shortcuts. It'll save you so much trouble.
I 100% agree. Like that is by far my favorite thing. When it showed up, I like live and die by the S key and the customized commands on that. Jeremy, we had some additional questions come in that I think we can talk about here. Engineering Tech says, what basic knowledge should we have before learning how to make a robotic arm, or maybe how to tackle a robotic arm?
Oh gosh. Okay. So first, it took a lot of guts for me to go after this with the knowledge that I had. So it's hard for me to even describe the Mount Everest that you're trying to climb here. It is every one of the disciplines that are involved. I'm not trying to scare you off. I'm just trying to give you the most realistic picture that I can. Every one of these skills has its own mountain to climb. And then when you combine them, it's definitely the pinnacle, in my opinion, one of the pinnacles of engineering to try to tackle, short of going to space and trying to build a space shuttle. This is like one of the real, it crosses so many disciplines. I think a better way to think about it would be, do you have the mechanical design background to at least make something that, won't shake itself to death, that you can think about moving a design that has moving components, remembering that each axis is dependent upon the one below it. So if there's any play in the first axis, that's going to be added to the play in the second and the third and the fourth and so on. So any error will multiply throughout each axis. So your mechanical design background needs to be really solid. And then do you have the the manufacturing experience if you want to build it yourself, to build something as complex as this. Yeah, I mean, each one has its own challenges. The electrical design is also really challenging, and because you're working with a lot of different components that need to work together. So I'm not even really sure how to explain in a couple of minutes all the different challenges that you would be going after. I think it's better to start with, figuring out where you are now, and then try to understand the gaps that you need to fill. It will be easier for you to answer the question, I guess, maybe is the way I want to answer it, than for me to try to answer it generically.
Yeah, and
It's
because
hard to
I think
say.
what people maybe don't, unless they've seen your channel, maybe don't fully grasp is like, one, like you're right, like every part of this robot is almost a 4-year degree discipline in and of
Yes.
itself. And then, like, we haven't really talked about it, but like you're really skilled. You're really skilled in the manufacturing side of this. Like you said, like you're doing
Yeah.
CNC programming, you're welding, you're doing all these other disciplines that are just amazing to watch. But yeah, it's almost like, do you have the desire to learn? Like, because that's what you're going to need to to make it.
We mentioned the that video where kind of the summary video for this project, building this 7-axis robot. That video will give you a really good snapshot. That was what I was going for. I wanted to, like, how do I summarize 2 years of work, in something that's, maybe 30 minutes or so long.
Yeah.
And that's what I came up with that video. And that'll give you a good sense of, I spent, I tried to spend an equal amount of time talking about the different things that, came up along the way. And if you want to watch the whole series, which is about 7 or 8 videos long, you can go even deeper and see the kind of challenges that you have ahead of
Yeah.
you.
So I had another good question come up. What language did you use to program the reverse kinematics? And what was the approach to this?
Oh boy. Okay. So there were.
I love that every answer starts with "oh boy."
Yeah, there was like, I used JavaScript. I used oh gosh, I went a couple of different ways. Remember, this was 2 years,
Yes.
so I was changing things up along the way, and I don't know that I could give a fair answer to that. There's one video where I talk about programming. I think it will be better to refer you to that video. I tell you what I'll do. Oh, sorry, I opened something there. Okay, so I think it will be better for you to check the video on that. I do talk about that briefly. Sorry to give that evasive answer there, but in the end, I ended up using an off-the-shelf component. So I also want to be fair to that as well. That what you see in the very last video, was not programming that was completely original to me. There are parts of that that's being handled by a store-bought machine, and so
Gotcha.
yeah, I think I want to leave the answer there.
Yeah. So another question that came up, and I was just looking at this one. As a manufacturing engineering student, I'm curious, how can one save costs when working on projects that involve frequent iterations?
Well, one of the things that I did with Jarvis, which brought about its own challenges, remember I said earlier, there's always a trade-off, is I bought a lot of used components. I would go to eBay and search for, or, actually there are several industrial auction sites that I used I got a few things from eBay, but I actually used a lot of different websites. And the catch is, even if let's say you bought the gearbox, uh, gearboxes come in many different configurations themselves, and you may not find exactly the one that you want. So I also ended up designing, adapters to make the used component that I bought fit my robot arm. And so you're going to run into pros and cons here and there. And if you end up changing that component, then you also need to change the adapter, right? So you will save a lot of money. I mean, in some cases, I was only paying 20% of what that part would cost new. especially the strain wave gears, which are really expensive.
Mm,
I saved a lot of money there, but in one case, I ended up changing one, and you spend a lot, and then I had to make all new parts to make it fit again. So that's just one of several ways that you can save money. Actually, I have a video about that as well. God, I can't remember the name of it off the top of my head, but it's something about like cost saving tips and tricks and things like that. And the whole video is about how I go about saving money on projects. So keeping the cost low. And
nice.
there's a heavy emphasis on using, uh, used parts, and how do I make templates, cutting templates out of wood first, or 3D printing test components to just make sure things fit. I did
Mm,
that with the robot arm. That end piece was 3D printed first. And before I machined it, I just made sure that it's the right size, it fits, it moves. It couldn't bear any weight, but I could make sure that the fit was good before I machined it out of metal.
nice. Nice.
Mhm.
Jeremy, this has been extremely insightful and a whole lot of fun to speak to you about. Is there anything you would like to plug? Additional videos, your channel, anything you'd like to point people to?
Oh gosh. I think we've already tagged a couple of videos. I think maybe what I'll do is go in the chat and just post one comment that has like 2 or 3 more video references, because I brought up several things. I want to try to find that video related to the programming question and also the cost saving question. So there are probably a couple more videos I could link to, but
Nice.
yeah, that would be probably easier offline to find and add that information.
That's great.
Mhm.
Yeah, well, thank you again for taking the time to walk us through this, and for Jarvis. It's super cool to see all your hard work come to life. And you and I were talking about this before we got on, but just your genuine excitement when it works at the end, and you could tell it's just like 2 years of hard work, and it's like, this, it works. Is
So many failures along the way. Yeah. Yeah.
Well, for those of you that are in our audience, thank you guys for all your great questions, your comments, and joining us today. Be sure to join us next week. We'll be back with SOLIDWORKS Live, and we are going to give and provide some sneak peeks to World. On December 17th, we'll look at the design domain. On the 18th, we'll dive into simulation. And on the 19th, we'll be looking at manufacturing. So join us next week for those previews. Man, it's hard to believe that World is already coming up. And Jeremy, I think you mentioned you're going to be there, right?
Absolutely. I'll be walking on the floor. I hope to see some of you guys there.
That's fantastic. I'm looking forward to meeting you in person there as well. So with that, we want to wish everyone a great Friday. Have a wonderful weekend. And Jeremy, thanks again, man, for joining us here today. It's been fun.
Great. Thank you.
All right.
Bye.
See you, everyone.